Hello, guys. Welcome back to Maths Zone African Motives. We are still on our grade 11 mathematics. In our case, we are going to consider a controlled test which was written in March 2025. So that is for a revision purpose for you to understand what the typical questions that you can be given in your March controlled test. So that was from Mpumalanga province. So we are going to add other provinces, all right? As long we have the papers, we are going to add those so that you can see different ways on how the questions can be given. So this was out of 50, that is the marks, 50 marks, and you were required to write this one in 60 minutes. So let us quickly go through the instructions. Make sure that you read every instruction. And also, you can download this question paper if you check the description of the video, or you can check the comment or in the comment section. I'm going to pin a comment which has got the question paper and the memo so that you can go through and see how to attempt in other ways, because there are other ways. I might not explain that concept, but being applicable, so you can go through and see uh, other ways of answering. All right. So I'm not gonna waste your time. Let us quickly go through our questions. Remember that we must have our answers to two decimal places. All right. So we have everything, the numbering, answers, right? Everything. Make sure that you go through each and every part, and we are going to leave our answers to two decimal places unless stated otherwise. All right, number one, question one, 1.1, you're given to solve for x. Solve for x. All right, so let's consider 1.11. This equation that we are given, we can see that that is a quadratic, all right? So we've got a quadratic equation, which we do understand, first of all, the format ax squared plus bx must be equal to what? To 0. So meaning to say, in our case, we must transpose the 8 to the other side so that we remain with a 0 on one side of the equation. So meaning to say, you are going to rearrange and have x squared minus 2x. All right, so 8 to the other side of the equation is going to be a negative. So that is equal to what? To 0. So you need the format. Then you can solve your quadratic equation the way that you understand. When you are not told that your answer is supposed to be to two decimal places like this, you know that even factorization is what is applicable. So meaning to say, you can factorize, you can use the quadratic formula. It is in your hands. So here I'm just going to take advantage of the coefficient of x squared, which is 1. So meaning to say, we are going to have two brackets equal to 0, and that's x and x to give us this x squared. All right, so considering the factors or the products of negative 8, which will add up to negative 2. So we need products, two factors of what? Negative 8. The factors or what? Products. When you multiply the two numbers, you must obtain what? Negative 8. Negative 8 and 1. There are so many numbers that we can actually use. And in our multiplication, we are obtaining what? A negative 8. But which of these, when we add, we must obtain what? Negative 2 when you add. So if you add here, all right, which one is going to give us what? A negative 2. That is negative 4 and 2. Negative 4 plus 2 gives us a negative 2. So these are the ones that you're going to put in the brackets. minus 4, and what? A plus 2. So that's your factorization, guys. With these two brackets, to obtain the values of x, you can simply equate each bracket to 0. So that's minus 4 to the other side was going to give us a positive 4, or x is equal to a positive 2 to the other side was going to give us what? A negative 2. So these are the possible values of what? The possible values of x. So moving on, that's 1.12. We are asked again to solve for x, but we are told that answer correct to 2 decimal places, meaning to say our factorization this time is totally limited. You are left with a quadratic formula, or you can use completing of the square method. So most of you guys, you are used to the quadratic formula. I'm just going to apply that for x squared minus x minus 2 is equal to 0. So as we can see, already we have got the basic format, the format that is needed. All terms on one side of the equation and the other side is equal to 0. So from this, this is our a, the coefficient of x squared. B is the coefficient of what? Of x. Meaning to say, in our case, that is what? -1. And c is the constant. So we can use our quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac. So that is the concept. You can easily apply the formula to obtain the possible values of x. So that's minus, our b is what? -1. So you're going to have plus or minus the square root of b, that is -1, remember, but we must square this. Minus 4 times our a, which is 4, and our c is what? -2. So that is it. Everything over what? Over 2a, which is 2 times 4. So that is the application of your quadratic formula. And I always say that try by all means to simplify this part that is under the square root separately, all right? Minus and minus, that's a positive. So you're going to have plus or minus. Simplify this part under the square root, only the numbers under the square root. All right, so we have got -1 squared minus 4 times 4 times negative what? -2. So this was going to give us what? 33. So that is 3 under the square root. And 2 times 4 is what? Is 8. At least try to simplify this stage to see the number that is under the square root. So as we can see here, we can simplify, and we're going to have two different answers, all right? So x is equal to what? You can simply use your calculator. 1 plus the square root of 33 over what? Over 8. So that was the first answer, 0.84 to 2 decimal places, or you can just fix your calculator to 2 decimal places. That's what? 0.84, or x is equal to, all right, let us put a negative this time. So delete the positive, put a negative, that is negative 0.59 to 2 decimal places. All right, so these are the possible values of x that we are going to have from our quadratic equation. You are all right. Using the quadratic formula, we can solve that. Let us move on. 1.13. It is still solving for x, but this time we have got an inequality. So that's an inequality that we are given on 1.13. So we are given that x into x minus 1 is greater than or equal to 6. Remember that an inequality, guys, as long it is a quadratic inequality. In our case, we are referring to a quadratic because the moment you multiply x and x, that is going to give us x squared. So that's a quadratic. So as long you have got a quadratic, you're going to need the format which is similar to a quadratic equation, only that now you're going to be having an inequality sign. Is it greater than what? But one side must be a 0. All right, so let us expand our brackets first, then we can have that format. As we have got a bracket here, we are going to distribute x into the bracket. That is going to be x squared, then x times -1, that is negative x, greater than or equal to 6. So this is the part that I'm explaining here to say we must have all terms to one side of the inequality, then one side being a 0. So we're going to take -6 to the other side. Positive 6 is going to be a -6. X squared minus x minus 6 is greater than or equal to 0. We no longer have any term on the right hand side. So thus, we can factorize. All right, here we can just factorize. We have two brackets that's greater than or equal to 0. As we can see, the coefficient of x squared is 1. So we're going to have x and x here. Then consider what? The products as before of -6. But these products should give us what? A -1 when we add the terms. So that's -6. We've got -6 and 1, 6 and -1, -3 and 2, 3 and -2. So which of these factors that when we add, we are going to have what? A -1. So this is occurring between these two. -3 plus 2 is what? -1. So that's a -3 and a +2. So this will give us the critical values now. So the critical values is when you are solving this as a direct equation, x minus 3 into x plus 2 is equal to 0. So meaning to say x is going to be what? A +3 on the other side, or x is going to be a -2 on the other side. So these are the critical values, the ones that we are going to use now to determine the exact solution to the inequality. So which stage can we use? We can simply go back here to stage, all right, at this stage here, where we are given the whole part here of x squared minus x minus 6 is what? Is greater than 0. It simply tells us that the function that we are going to have, when it is greater than or equal to 0, we are referring to a condition that is above the x-axis. But that function, we can consider its shape, all right, as x squared minus x. This part of x squared tells us about the shape ax squared plus bx plus c. The a, this one, gives us what? The shape. So for a is greater than 0, it's going to be concave up. Then for a is less than 0, it's going to be facing down, concave down. So in our case, a is what? Is 1. The coefficient of x squared is 1. So meaning to say it's going to be facing up, concave up, like this. And the solutions on this part where the curve and the x-axis meet will be -2 and what? And 3. So -2 on the left side, 3 on the right side. And I say that when the function is greater than or equal to 0, we're talking about what? Above the x-axis. So in our case, the solutions will be here above the x-axis. So that's x is less than -2 to the left of -2. So therefore, x is less than or equal to -2. Remember, there is an equal to there. Or x is what? On the other side, it will be greater than or equal to 3. So that is the concept or you can simply use the number line concept. All right, we have got -2, +3. So we are going to need a condition where we substitute into any of these part, but as we can see that we are given that whatever part of x or of the function it is greater than 0, meaning to say it is positive. So we need conditions which will give us what? Positive values. So you can try values that are less than -3. I mean -2, values less than -2, such as -3, -4, -5. All right. Substitute in this part on these in these brackets, whatever case we are between these two, you can use the brackets. All right. So let me just use the brackets. All right. Let me go back to the normal mode. All right. So I'm just going to use brackets. So it is x -3. So our x, I'm going to choose -3. Any value that is less than what? -2. This side. Values less than what? -2. All right. -3. So that's -3 -3. All right. Then I close the bracket. Open another bracket. It is what? X plus 2, and our x is what? -3. So that's -3 plus 2. All right, this is going to give us +6. So like I said, we need a condition that will give us what? Positive values. So here we are obtaining positive, which is exactly what we want for values that are what? Less than -2. What about in between -2 and 2? Values that are in between, we can choose anyone. Can even choose a 0 there. All right. So if our x is equal to 0, just substitute in place of x. So x here is now, that's a 0. X here is what? Is a 0. So that was going to give us -6. We are obtaining a negative value, which is not what we want. We need a positive. So this region is out. All right. From 3 going to the right, these values, they are greater than 3. So any value greater than 3, 4, 5, 6, whatever that you want. So I'm just going to use 4. In place of x, I'm going to put a 4. In place of x, I'm going to put a 4. So this is going to give us 6, which is a positive. So this region gives us a positive, exactly what we want. So that is the two regions satisfies the condition. This region of values that are less than -2. So this is less than or equal to -2. Or this region for values that are greater than 3. So that is x is what? Greater than or equal to 3, this condition. So you can even consider the number line, or you can use the graphical method to obtain exact values. So this one, it is in your hands. All right, so it is actually in your hands. You can just play around the way that you understand. At the end, you must have some answers at the end. All right, 1.14, solve again for x, and we have got 5 marks for that. All right, so these are equations that we have under our surds. All right, so we are given 1.14. All right, sorry, 2x plus the square root of x plus 1 is equal to 1. So remember, when working with the surds, what we can do here is to consider the part that is under the square root, that is our surd. We must isolate that. So the first stage, we need to isolate to make sure that the terms under the square root are only found on one side of the equation to isolate the surd. So it's going to be square root of x plus 1 is equal to, you take the 2x to the other side. You must get rid of that. So simply subtract what? Subtract 2x. So it's going to be 1 minus 2x. we have isolated, we have a surd on one side of the equation. What are we going to do to get rid of the square root? We have to square both sides. So in our case, you are going to square both sides of your equation. So you have to square. Squaring here is removing or getting rid of the square root. The moment you square, you get rid of the square root. So you remain with x plus 1, which is equal to, on the right hand side, you are going to square this bracket. Simply means we have got two brackets, 1 minus 2x, 1 minus 2x. So you can expand from your FOIL method, all right? Or you can just consider, remember, a minus b squared is equal to a squared minus 2ab plus b squared. So as long as you've got two terms inside the bracket, you can consider one a and another one a b. So using this is the first term a, and here it's being what? Squared. So meaning to say you are going to square the first term. 1 squared is equal to what? To 1. Minus 2ab, thus we are going to have minus 2 times a. Our a is represented by 1. Our b is what? The 2x. So take note, guys, this is a, this one, minus b. Our b is 2x. The minus is the sign that is in between. Your a is 2x. Your a is 1. Your b is 2x. So take note on this part. So negative 2 times 1, that's negative 2 times 2, negative 4x. All right, so that was going to give us negative 4x, all right? Then b squared means the last term squared. You must square the last term, which is what? Which is 2x. Let us square it. 2 squared, you are raising 2 to the exponent of 2, which is 4. Then x also raised to the exponent of 2. So that's what? 4x squared. All right, so this is your condition. We have removed the square root by squaring both sides. Now that we have removed the square root, we can see that what we are forming, or what we have formed here, is a quadratic equation. So you're going to need the format back again of what? A quadratic equation. Ax squared plus bx plus c is equal to 0. One side of the equation must be equal to 0. So we can let the left-hand side be equal to 0. Just move these terms to the right-hand side. So that's 0 is equal to. So I'm going to start this part of what? X squared. Ax squared. So that's positive 4x squared. Then we have got minus 4x, which is going to be affected by x. Remember, we're taking x to the other side, so it is going to be a negative x, all right? It was a positive. Then we have got a 1 already on the right-hand side. Then if we take this 1 to the other side, it's going to be a negative 1. So that's it. 0 is equal to 4x squared. Working with the like terms, this is negative 1 minus 4 minus 1. That's minus 5x. 1 minus 1, that's a 0. So this is what you're going to have. So we can simply rewrite. Remember, if a is equal to b, it simply means b is equal to a. So I can just rewrite, starting with what I have on the right-hand side being equal to what? To 0. I haven't changed anything, guys. Yes, you can just work as it is on the right-hand side. It does not even affect anything. So you can use a quadratic formula, but c is equal to 0. But guys, you can see that if there are just two terms, and these two terms have got something in common, which is x. X is what? Is common. So you can factorize. All right, you can factor out the x, which is common. So 4x squared divided by x, that's 4x. Minus 5x divided by x is what? Minus 5. And that's equal to 0. And from the zero concept, one of these two is supposed to be equal to what? To 0. So that's x is equal to 0, or this bracket is equal to 0. 4x minus 5 is equal to 0. All right, so already here we have got a solution, but remember we have to test our values. So let us solve for this one. 4x is equal to negative 5 to the other side. That's a positive. So divide by 4. X is going to be what? 5 over 4. So that is the value of x. 5 over what? 5 over 4. So we need to test, as long you are working with surds, equations under surds, you must test the values, this value and this value. All right, so it is easier for you to test, guys. Just refer back to the original equation. All right, for when x is equal to 0, let us start with that one. When x is equal to 0 is 2 times a 0 there plus the square root of what? X is what? It's 0. So that's 0 plus 1. All right, this is going to give us a 1. Exactly what you have on the right-hand side. 1 is equal to what? 1 is equal to 1. So it means x is equal to 0. When x is what? 5 over 4, do the same thing. In place of x, you put what? 5 over 4. In place of x, you put 5 over what? 5 over 4, like that. So that was going to give us a 4. And we can see that 4 is not equal to 1. So meaning to say x cannot be equal to what? 5 over 4. So the only solution that was going to satisfy our answer here, our equation, is that x is what? Equal to 0. So you're supposed to test, guys. All right, test your values. That is what we had on this one. All right, as you can see, it was just a follow-up question. You just have to follow up. It's just a little bit lengthy, but everything was just direct. 1.2, solve simultaneously for x and y. So we need to solve for what? Solve for x and y in these equations. So already this is your equation 1 and this is your equation 2. And it depends on the method, but when you are given a linear equation, one is linear and another one is a quadratic. As you can see, the highest exponents being what? Being 2. It is best that you apply the substitution method. All right, so that is the easier way that you can actually attempt this question using what? Substitution method. Substitution method. All right, substitution method. So what you're going to do is to look into the equations. Pick one equation that you can make x or y the subject. But when working with the linear and quadratic, it is best that you make the subject from the linear equation. And from our linear equation, it is easier to make y the subject. As you can see, y is just a single term. We do not have any other number affecting y. So I'm going to make y the subject. So y is equal to 7 minus 4x. So I'm going to name this equation 3. We made y the subject from equation 1, all right? From equation 1. So once you have got y as the subject, you are going to substitute that into another equation, meaning to say in equation 2. So you are going to substitute equation 3 into what? Equation 2. So that is in place of y, you're going to put what? 7 minus 4x in place of y, where there is y. So that is the condition. All right, so this was going to be 3 x squared plus 2x, but y is what? Represented by 7 minus 4x. So in place of y, you're going to put 7 minus 4x, all right? That is 2xy. 2xy, but y is what? 7 minus 4x. This is equal to what? Y squared. So it is equal to y squared. Y is what? 7 minus 4x. So it means you are going to square that. 7 minus 4x. You are going to square this. So that is the condition. That is our condition. You make y or x the subject from one equation, then you substitute into the other equation. So with this, you can solve for x, because as you can see, we're just left with x. So what can we do? Let us expand our brackets, clear this part. So let us just expand and collect our like terms. All right, so this is 3x squared plus, here we're gonna distribute by what? By 2x. As we can see, I've got a bracket and there's a term outside of the bracket, so it's gonna be 2x multiplying a 7, 2x multiplying negative 4. So 2x times 7, that's gonna be 14x. 2x times minus 4, that's minus 8x squared. All right, then we expand this other side. Like I said previously, it is in your understanding, guys, you can have two brackets, 7 minus 4x, another one 7 minus 4x. You expand them. Or you can simply use the last previous concept of a minus b squared is equal to a squared minus 2ab plus what? B squared. So you must know the expansion. So in our case, a is 7 and our b is what? 4x. So a is going to be 7, our b is going to be 4x. So a squared, our a is what? 7. 7 squared is what? 49. Just like that. So this is equal to 49 minus 2ab. So that's minus 2 times a. Our a is 7. Our b is what? 4x. So this was gonna give us, all right, 14 by this negative 56. All right, so this was gonna give us negative 56x. Then the last part is b squared, the last term squared. That's 4x squared. 4 squared, 4 times 4, that's 16. Then x is also being what? Squared. So that's plus 16x squared. So that is a condition. That is where we are, guys. We can simplify the terms on the left-hand side. Collect your like terms. 3 minus 8. 3x squared minus 8x squared. So 3 minus 8 is negative 5. So you're going to have negative 5x squared plus what? Plus 14x. And that is equal to what you're having on the left-hand side. You can even start by this 16x squared minus 56x. All right, plus what? Plus 49. Just our quadratic equation concept. So this is where we are. And we can see that this is a quadratic equation that we have. So still we have to go back to the format. Ax squared plus bx is equal to what? To 0. One side must be equal to 0. So we can move the terms, the fewer terms, these ones that are fewer, on the left-hand side, move them to the what? Right-hand side. So that's, we're going to have a 0 here. So minus 5 to the other side is going to be what? Positive. So that's 16 plus 5, which is 21x squared. All right. 14x to the other side is going to be a negative. So that's minus 56 minus 14. That's minus 70 minus 70 plus what? 49. So this is what we have, and we can even reduce our equation. As we can see, 7 is the highest common factor. So we can just reduce by 7. 0 divided by 7, that's a 0. This one and this one is going to give us 3x squared minus 10x plus a 7. All right, so that's a simpler quadratic equation, as we can see that we can work with. 3x squared minus 10x plus 7 is equal to 0, where you can use your quadratic formula, or you can even apply the factorization. All right, trying the factorization, you know that we're going to have two brackets, so it depends with the method. And under that factorization, there are ways of factorizing. So I'm not going to limit you to one way or something, guys. Use the way that you understand, all right? So I have done a video on the cheat method where you can multiply 3 to 7, and that's, you get rid of that 3. So it's going to be x squared minus 10x. 3 times 7 is positive 21. So the reason of taking these 3 is that we are going to have or remain with a positive 1. Remember the coefficient of x squared. If it is 1, you can easily factorize, put x and x here. Then you consider the factors of positive 21, which will add up to negative 11. So there are so many factors, guys, but I'm just going to rush negative 3, negative 7, and negative 3. If you multiply these two, you obtain positive 21. If you add, you're going to obtain negative 10. So these are the ones that we need. Negative 7, negative 3. But this is not our answer because we removed the 3. So we're going to get, we're going to replace our 3 in each bracket. So you're going to also put a 3. In place of x, you replace the 3 that you removed in the first place. Where factorization is applicable in these brackets, do factorize. Like the second bracket, we can see that 3 is common. So we can factor out the 3, and it's going to be 3x divided by 3, that's x, minus 3 divided by 3, that's minus 1. And this bracket remains as it is, 3x minus 7. Once you've got this, guys, you can get rid of that 3 that you factored out. It is a useless term, not to be applied. Your answer are these two brackets that you have. From this way, which is the cheat method, under your factorization. So guys, like I said, do not be limited to my method. There are so many ways on how to factorize. Do that. Your answers will be the same at the end. If you are obtaining two brackets different from what I'm having, know that your answer is wrong. You must correct, redo your method again. So that is it. We can solve for x. From the zero product, this equate to that is going to be x is equal to 1, or take minus 7 to the other side is going to be positive 7. Definitely, you're going to divide by what? By 3, all right? 3x is equal to 7. If you take this, then you divide by what? By 3, by 3. This is what I'm saying. So x is equal to 1, or x is equal to 7 over 3. These are the possible values of x. These are the values of x that we are having from our solution. What about the values of y? We can obtain easily the values of y from equation 3. Remember, in equation 3, we already made y the subject of the formula. Y is the subject already. So it is easier for us to use equation 3. Y is equal to 7 minus what? 4x. So you can simply use equation 3. Y is equal to 7 minus 4x. So meaning to say, to obtain the possible value of y when x is equal to 1 is going to be 7 minus 4 times, in place of x, you put a 1. So that was going to be 7 minus 4, which is 3. Or y is equal to 7 when x is 7 over 3. In place of x, you're going to put what? 7 over 3. So that was going to give us the value of y from there. 7 minus 4, open bracket, 7 over 3. So this is going to give us negative 7 over 3, just like that. So these are the values of y corresponding to the x value. When x is 1, y is this. When x is 7 over 3, y is negative 7 over 3. So it depends also with how you solved in the first place. Maybe you wanted to make x the subject. It is in your hands. You can make x the subject, but here I just chose y. It's easier for us to work with y as what? As the subject, but you could have even made x the subject. It is still okay. But at the end, you are going to have what? Same answers at the end. So this is what we obtained. All right, let us move on. Let us move on the other part and see how these questions, guys, are given. It's all about revision, as you can see. It's all about revision. You must do revision in as much as you can. 1.3, the roots of a quadratic equation are, these are the roots when you solved your quadratic equation using what? The quadratic formula. This is from our quadratic formula. We expect to have something like this. Then we are told calculate the values of k for which the root or roots are equal. We do understand, guys, for equal roots, when the roots are what? When the roots are equal, it is all about our delta. The discriminant is supposed to be exactly equal to 0. And what represents this, the discriminant? It is the b squared minus 4ac. What is under the square root? So here, what is under the square root is our delta. So our delta in this case is what? 13 minus 2x. What is under the square root? B squared minus 4ac. And we are saying it must be equal to what? To 0. So you have to solve an equation. 13 minus 2k is equal to what? To 0. Solve for k. Minus 2k is equal to 13 to the other side is going to be a negative 13. So to find k, simply divide by what? By negative 2. So that is going to give us the value of k, which is positive 13 over 2. Or you can write this as 6.5. So that is how we can be given this. All right, just for 2 marks. Another part, working with this discriminant concept, the roots, the nature of roots. Given that this bracket is equal to this, calculate the values of p for which the roots of the equation are non-real. So if the roots are non-real, what is the concept? We do not have solutions. So delta is less than 0. It's a negative value. What is under the square root is a negative, so that you cannot obtain any real value. There will be non-real values for that concept. So we need delta, which is what? B squared minus 4ac. So for you to properly say the b squared minus 4ac, you can expand the brackets, or you can just solve direct here from what we have. Because when you solve, you're going to have a part that will be under the square. The part under the square root is your delta. Or you can simply expand. So this was going to give us x squared plus, when it is a positive, it's going to be a squared plus 2ab plus b squared. So 2ab multiply 2 times a times b, 2 times x times what? times 5, which is going to give us 10x plus b squared. Our b is what? 5, and 5 squared is 25. So that is equal to 1 minus p squared, what is on the right hand side. So this is what you have. 1 minus p squared is a constant, this one. We do not have x, so it is a constant. So you can take it to the other side of the equation, as we do understand that one side must be equal to 0. So 1 to the other side was going to be a negative 25 minus 1, which is what? 24. All right. Then if we take minus p squared to the other side, it's going to be a positive. So it's going to be positive what? P squared. So that's equal to 0. So 24 plus p squared, this one, it is a constant. We do not have x there. So here, this is our a, the coefficient of x squared. Our b is 10, and our c is 24 plus what? P squared, the constant, where you do not have x at all. So we need your delta. So that's our delta, which is equal to b squared minus 4ac is going to be equal to b. That's 10 squared minus 4 times a. Our a is 1 times c. This is our c. 24 plus p squared. All right. So that is it. Our delta is going to be 10 squared, 100. 4 times 1, that's a negative 4 here, into 24 plus p squared. Don't be tempted to subtract these two, guys. Remember, BODMAS, there is a bracket. So the negative 4 has to expand the bracket first here. You must expand the bracket by what? A negative 4. So meaning to say it was going to be 100 minus 4 times 24. So take note, you must expand by negative. So that's negative 96 minus 4 times p squared minus minus, that's minus, so it's minus 4 p squared. So meaning to say our delta is going to be 100 minus 96, which is 4, minus 4 p squared. This is our discriminant, our delta, which must be less than 0 for us to have non-real roots. So that is the condition that we're going to use. It is less than 0. So this whole part, 4 minus 4p squared, is less than 0. You are back to inequalities. It's no longer about equations. Back to inequalities, and that's a quadratic inequality. The highest exponent is what? The highest exponent is 2. So depending with the way that you want to solve, you can easily just factorize and have your values. It's up to you, but here you can even get rid of the negative 4, divide by negative 4. Negative 4 throughout. Negative 4, that's positive 1. So it's going to be p squared. All right. 4 divided by negative 4, that's a negative 1. Remember, under inequalities, the moment you divide by a negative, like what happened here, the inequality sign reverses, or it changes. So it's going to change to be a greater than sign. So that's greater than what? 0. So this is it. We just avoided working with a negative on the coefficient of p squared. Not to say you cannot do that. You can, but you can just avoid divide by negative. But don't forget to change the inequality sign. So for you to solve for p, this is a difference of 2 squares. P minus 1 into p plus what? 1 is greater than 0. So meaning to say p is equal to what? Having our critical values. Minus 1 to the other side is going to be positive 1. Or p is equal to positive 1 to the other side. That's a negative 1. So these are the critical values, the ones that we are going to use now to obtain the exact values of p. It's either you're going to use the graphical way, or you're going to use the number line. All right, minus 1, this is positive 1. So here I'm seeing this from the coefficient here of p squared, it's 1. So that's our A is greater than 1. So it's going to be concave up. All right. And being greater than 0, it means we're talking about above the x-axis. So your solutions can be here or here. So meaning to say P is what? Less than -1 to the left side. P is less than -1, or to the right side of 1, P is what? Greater than 1. So that is the conditions that we are going to have. Or like I said, you can simply apply this on a number line. All right, so many ways of determining exact values. So that was it on question number 1, carrying 28 marks. This part of number 1 was the one that was carrying a lot of marks, but let us see the other part as we are having it. So as we consider question number 2, 2.1, simplify the following without using a calculator. And your answers must be free of negative exponents. You are not supposed to have negative exponents on your answers and irrational what? Exponents. All right. So let's start with the first one. 2.11, 3 to the exponent of 2n plus 2. All right, 9 to the exponent of n minus 1. There's something, guys, about the 2n, and that can also be obtained from this 9 here, because 9 is the same as 3 to the exponent of 2. All right, so we can actually obtain the 2n, the 3 to the exponent of 2n, something that is common. So let me just rewrite this 2n plus 2 minus 3 to the exponent. This is going to be, you just distribute because it's exponent to exponent. So 2 times n, that's 2n. 2 times -1, that's -2. All right, everything over 2 times 3 to the exponent of 2n plus 1. All right. So we can see that the 3 to the exponent of 2n is something common that we can actually base with when answering our questions. So what we can do is to separate our terms, separate our exponents, 3 to the exponent of 2n and 3 to the exponent of 2. We separate that. So it is the same as 3 to the exponent of 2n times 3 to the exponent of 2. Minus, you do the same here, 3 to the exponent of 2n times 3 to the exponent of what? Minus 2. Everything over 2 times, we separate again here, 3 to the exponent of 2n times 3 to the exponent of what? 3 to the exponent of 1. So this is what you're going to have. And in the numerator, because we have two terms, there is this term and this term, because they are separated by what? The negative sign. We can factorize. So in the numerator, we are going to factorize, factor out the 3 to the exponent of 2n, which is common. So you're going to remain with 3 to the exponent of 2 minus 3 to the exponent of minus 2. Everything over what? The denominator is just going to remain as it is. That's a single term. There is no way that you'll be saying I'm factorizing 3 to the exponent of 2n. These are under multiplication here. It is separated by what? A subtraction. When you're subtracting or adding, you can factorize. But advantage is that the numerator and the denominator, as we have got a product, these two terms are the same. You can cancel out that one. So meaning to say, I was going to remain with 3 to the exponent of 2, which is 9. 3 times 3 minus 3 to the exponent of minus 2 simply means 1 over 3 squared. So it's 1 over what? 1 over 9. Everything over 2 times 3. 3 to the exponent of 1 is 3. So multiply by 2, that's a 6. So thus, we can subtract, all right, 9 minus what? 1 over 9. This is 9 minus 1 over 9. All right, so 9 is same as 9 over 1. So that's the LCD was going to be 9, and this one into this one, it's 9 times 9, which is 81, minus 1 here. So it's going to be 80 over 9. All right, so the numerator is going to give us 80 over 9 over 6. So it simply means divided by what? By 6. And 6 is same as 6 over 1. So that's 80 over 9 times 1 over 6. You introduce multiplication, then you invert the second fraction. So it's going to give us 1 over 6. So that was it. We can simplify this. We can simplify this, all right? By 2 here, that's going to give us a 3. By 2, that's a 40, divided by 2. So you can multiply the numerator to the numerator. 40 times 1, that's 40 over 9 times 3, which is what? 27. So this was going to give us 40 over 27 at the end. As you can see, this cannot be simplified any further. All right, so yeah, these are some of the typical questions. They can be given in this manner. Just try to separate your terms, factorize where possible. All right, 2.12, that is under our surds. All right, so there is 3 minus the square root of 3 squared, everything over the square root of 3 times the square root of 6. All right, so under our surds, we can easily expand these. There are two brackets, 3 minus the square root of 3 into 3 minus square root of 3. It's fine, you can do that. Or you can use the expansion that I used before, the a minus b squared. A minus b squared, which is equal to a squared, minus 2ab plus b squared. So our a here is 3, and our b is the square root of 3. So when we need a squared, it means that's 3 squared, which is what? Which is 9, minus 2ab minus 2 times our a is 3, and our b is the square root of 3. So you can only multiply the numbers outside of the square root. Minus 2 times 3, that's minus 6 square root of 3. So it was going to be minus 6 square root of 3. Then the last term squared plus b squared. Our last term is what? Square root of 3, but we must square that one. Remember that square root of a times the square root of a gives us a. If you're multiplying two terms under the square root, they're the same. This is going to give us a 3, or simply neutralize that square root. So you're going to remain with what? Positive 3. So you have expanded this bracket by simply using this concept. And this one, we have square root of 3 times square root of 6. All right, we can just combine and see if whatever that you're going to have later on can be simplified. So under surds, square root of a can multiply square root of b. When two different terms, just multiply them as they are under the square root. So it's square root of ab, you multiply. This is 3. This is what? 6. You multiply the numbers under the square root. So 3 times 6 is going to give us what? 18. All right. And that 18 can be simplified, square root of 18. All right. So anyways, let us start with the numerators. Add these constants 9 and 3. Add those like terms. So that was going to give us a 12 minus what? 6 square root of 3. Everything over what? The square root of 18. Yes, you can rationalize the denominator here, but you can simplify it. The square root of 18 in simplest said, in said form as it is, but it can be written in simplest form, where you write it in as a product, a perfect square times an integer or number, actually positive integer. So the perfect square, the highest perfect square that we have in 18 is 9. 9 times 2 gives us 18. All right, or you write as a product of its prefect as 2, 9, 3, 3, 3, 1. Where there is a pair, you write it outside of the square root. Where you do not have a pair, you write it under the square root. So it's going to be 3 square root of 2. Or you can use this method, because we know that we can separate this and write as square root of 9 times square root of 2, where square root of 9 is what? Is 3. And what about square root of 2? We do not know. So it's going to remain as what? It's going to be 3 square root of 2 at the end in simplest form. All right. So this is where we are. We could have just rationalized our denominator at this part, but we can take advantage of the numerator between these two. 3 is the highest common factor, so we can factor it so that we divide by what? This one in the denominator. So factorize, 3 is common, like I said. So this is going to give us 3 into what? 12 divided by 3. That is going to give us a 4. 6 divided by 3, that's a 2. So that's 2 square root of 3. Everything over what? 3 square root of 2. So this is what you're going to have. And the 3 that is outside of the bracket can cancel this one as it is under a product. So 3 and 3 can cancel. So it means you were now left with a simpler surd. Yes, it is a simpler surd, but it must be rationalized as the denominator. We have square root of 2 and irrational, so we must rationalize that. So how is that possible? You multiply by the square root of 2, both the numerator and what? The denominator. So that's, you've rationalized the denominator. So this is going to multiply here. Square root of 2 times what? Times 4. That's 4 square root of 2 minus 2 square root of 3. 2 square root of 3 times square root of 2. So these ones, remember, they multiply each other under the square root. So 3 times 2, that's going to be 6. So this is 2 square root of 6. Everything over what? Square root of 2 times the square root of 2. Remember, square root of a times square root of a gives us a. If the numbers under the square root are the same, you're just going to obtain that number as it is under the square root, which is what? Which is 2. So that is it. And I can simplify the numerator again. 2 is common. Between these 2 is the highest common factor. So I can factor out 2. 4 divided by 2, that's 2. Square root of 2 minus 2 divided by 2, that's 1. So it's going to give us square root of 6. Everything over 2. So here we are to cancel. And this will be our final answer at the end. So you can have our answer as 2 square root of what? Of 2 minus the square root of 6. Yes, you can further expand this and factor out. It will be something like this. Square root of 2 times the square root of 3. Then you can factor out square root of 2. So it's going to be 2 minus square root of 3. Yes, you can have it that way, or you can just leave your answer like this. It is still okay. So those are some of the typical questions that you might have under your surds. All right, they want you to know your basics, all the basics. So go through the basics, revise your basics. All right, the introductions to the topics, know the basics of each and every part. Let us move on to another part of our question, which is 2.2. solve for x without using a calculator. And we had the first part 2.21. All right, this is the x root. It is the x root of 32, which is equal to 128. All right, remember, if you say the square root of x, it means x to the exponent of a half. The cube root of x to the exponent of 1 over 3. What is inside of the root sign is your denominator. So what is inside the root sign is what? X. So it's 32 to the exponent of 1 over x. It's going to be our denominator. And this is equal to 128. So how can we solve for x, guys? X is in the numerator. So we can play around with the bases 32 and 128. Can these two be written in the same base? Yes, they can, in the base of 2. Or just try to write them in simplest form. This is how you can have 32 as a product of its prime factors in simplest form. 32 is equal to, then you press shift fact 2 to the exponent of what? 5. This is the simplest form. 2 to the exponent of 5 raised to the exponent of what? 1 over x is equal to, what about 128? 128 is equal to, then you press shift fact. So no one is going to understand that you've used a calculator because you're supposed to actually know it by head. All right. Anyways, this is an exponent to an exponent. X to the exponent of a to the exponent of b gives us x to the exponent of ab. You multiply the exponents together. So this is 5 over 1 times 1 over x. 5 times 1, that's 5. 1 times x, that's x, which is equal to 2 to the exponent of 7. Remember that if the bases are the same, xa, x to the exponent of b, if these bases are the same, we can equate our exponents. A will be equal to what? B. So this is the same. We can equate our exponents as 2 and 2 are the same. All right, so that we can solve for x. So therefore, 5 over x is equal to 7. So let us solve for x. 7 is same as over 1. So you can easily cross multiply x times 7. 7x, 1 times 5, that's 5. So simply divide by what? By 7. That's, we have got the value of x from there. So therefore, x is equal to what? 5 over 7. So they can actually ask these typical questions. As you can see, they can have questions like that. So make sure that all basics are being done. You've revised every basic in your syllabus according to your term 1 annual teaching plan. All right. So let us move on to another part. 2.22, we are given this. All right. Let us see here, x to the exponent of 1 over 2. X to the exponent of 1 over 2 minus 3x to the exponent of 1 over 4 minus 10 is equal to 0. All right, so this is under our exponents. Again, we can have equations of that nature. Remember, I say these are simply disguised quadratic equations where we can work out from the least exponent 1 over 4 compared to 1 over 2. 1 over 4 is the least x, the smallest, all right? So we rewrite 1 over 2 in terms of 1 over 4. So it's going to be x to the exponent of 1 over 4, but raised to the exponent of what? So that we obtain the same answer as what? 1 over 2. So that's to the exponent of what? To the exponent of 2. Or you can simply say 1 over 4 times what? So that we obtain 1 over 2. So you divide by what? 1 over 4 like that. So x was going to give you a 2. So that's our exponent, all right? minus 3, this one remains as it is. Remember, we have to rewrite this one in terms of what? That x to the exponent of 1 over 4. So it must remain as it is. And by doing this, that's where you can use the substitution of the k method, using that in place of what? X to the exponent of 1 over 4, which is the one that we have as a common part here. So we can let it be represented by what? By k, or you can just solve as it is. If you introduce k, therefore it means this was going to be k squared raised to the exponent of 2 minus 3k minus 10 is equal to 0. All right. So it is easier for you to solve something like this. You are just used. And when you have got this, but guys, it was just going to be the same. We factorized. All right. But anyways, if you do not understand, then introduce your k, then you do factorize. All right. The coefficient of k squared is 1. So it's going to be easier for us to factorize, as we're going to have k and k. K times k gives us what? K squared. So what are the factors of what? Negative 10. And these factors are supposed to add up to negative 3. So there are so many factors of what? Negative 10. So many that we can list. But which ones will add up to a negative 3? All right, that happens between negative 5 and what? And 2. If you multiply these two, guys, you're going to get a negative 10. But when you add, that's a negative 3. So that's negative 5 plus 2. So for k, minus 3 to the other side is going to be positive 3. All right, or k is equal to positive 2 to the other side is going to give us what? Is going to give us a negative. So these are the values of k that we have obtained. But our question is not about solving of k. K was not part of our equation. It is something that we introduced. Our original equation is what? Of x, in terms of x. So we must solve for x. So we bring back that part where we introduced our k. We said k is what? X to the exponent of 1 over 4. So it means in place of k, I'm going to put that x to the exponent of 1 over 4 is equal to 3, or x to the exponent of 1 over 4 is equal to minus 2. All right, which is impossible, guys, to put a number here which is representing x. You raise to the exponent of 1 over 4 and obtain a negative. All right, that is impossible. So meaning to say there is no value of x that you can have. You are going to obtain it from here. This is a positive. So yes, we can have a positive value raised to a positive to give us what? A positive. But how do we get rid of the 1 over 4? The power. To get rid of the power, find its reciprocal. We need its reciprocal. 1 over 4, which is 4. So you multiply by 4, you raise to the exponent of 4. So this is going to give us x to the exponent of 1 equal to 3 to the exponent of what? Guys, where did I get the 3 now? This is negative 5. Where did I get the negative 3 here? All right, so let's correct here, guys. They said what? Negative 5. So this to the other side is going to be a positive 5. Sorry for that. So meaning to say here it's also a positive 5. Now raised to the exponent of what? Of 4. So 5 to the exponent of 4 is going to be 625. If you multiply 5 times 5 times 5 times 5, that's 625. Even if you use a calculator, no one is going to know that you have used a calculator, guys. When they say do not use a calculator, it does not mean totally. No, you can use it to raise these exponents. It's not a problem. All right. So as you can see, this is what you have. As we can see, this is what you have. So you're going to have a single solution for that. Make sure that you do the basics. Watch the videos where I have explained on the introduction of the topics, and that can actually help The last question that we're going to have is question number 3, which is under our trigonometry. So you're given 3.1 in the diagram below, the point P, negative 6y, remember, negative 6, 8, that's the x and the y value. So we are simply told or given that the x value is what? Negative 6. And the y value, this vertical, is what? Positive 8. All right. And is a point on the Cartesian plane where A is the point on the positive. This is our A. And angle AOP is what? Angle AOP is equal to theta. All right. This is O and this is P. All right. So that is it. So the first question here was to determine with the aid of a diagram the following the length of OP. All right. So from our diagram, guys, OP is this hypotenuse, as we have got horizontal and vertical lines meeting at what? 90 degrees. So OP simply represents the hypotenuse. So that is R there, all right, which is our hypotenuse, which we do understand that's the square root of x squared plus y squared. So meaning to say OP is the square root. The x value is what? Negative 6. And the y value is what? Positive 8. So that was going to give us the length of OP. Negative 6 squared, positive 36. 8 times 8 is 64. So if you add, that's 100. And the square root of 100 is 10. So that's 10 units. All right. So that is it, the length. Simply use the hypotenuse concept. That's our R, the square root of x squared plus y squared. All right. So that we have, as we have got this length, now you're asked to determine or calculate tan of theta. So tan of the angle theta. Remember the SOHCAHTOA concept. SOHCAHTOA concept. So tan, since we are in a right angled triangle, that's opposite over what? Opposite over adjacent. And according to theta, we use the angle that is inside the triangle, this one on the base. According to this angle, this is our opposite. This is our adjacent and our hypotenuse. So we need opposite 8 over what? Adjacent negative 6. So that's our tan of theta, which was going to give us negative 4 over 3. By reducing this, you're going to obtain negative 4 over 3. All right. Just like that. 3.12, you are done. 3.13 sine theta plus cos theta. All right, we can simply use the same concept. All right, 3.13, the sine of theta plus the cos of theta. Remember, sine is what? Opposite over hypotenuse. And the cos adjacent over what? Over hypotenuse. So our opposite, it's 8. All right, hypotenuse is what? Is 10. So that's 8 over 10 plus adjacent negative what? Negative 6 over the hypotenuse, which is what? Positive 10, the one that we calculated. All right, a plus and a minus is going to give us what? A negative at the end. So it's 8 over 10 minus 6 over 10. Where the denominators are the same, simply subtract what? The numerators. So that's 8 minus 6 over 10. And 8 minus 6, that's 2 over 10. Reduced by 2, that's 1. This one is going to be 5. So it was going to be 1 over 5 as a fraction in simplest form. If you are to write in a simplest form, this was going to give us what? 1 over 5. So these are the typical questions, all right, that you'll be given. So you need to work out as many questions as you can, do more revisions, all right, as you are working out your question papers. Where you do not understand, the comment section is there. Let us communicate. So that was the last piece of our question paper. We are going to look into other provinces, like I said, trying to understand all the basics. But for now, that is it. Till we meet again.